EV manufacturers beware. A new kid is on the block. Canadian electric car parts manufacturer Magna has recently revealed the all-new secret weapon they've been working on, which is their new high RPM electric motor. This new motor promises a lightweight package, double the power, and significantly better efficiency compared to most other motors currently in use. About Magna. First, we need to introduce you to Magna. This company might seem foreign to you. However, Magna is one of the most important and biggest vehicle parts manufacturers in the world. It is consistently being ranked as one of the biggest companies in Canada in general. They provide parts and facilities to many automotive companies all over the world, and they've been doing it for decades now. Mercedes-Benz, BMW, and Ford are only a few that keep sourcing their parts from Magna to this day. But with the EV revolution's start, Magna started heavily investing in making crucial components for EVs, as they expected that this would allow them to become one of the most prominent EV parts manufacturers and allow them to fully transition into a new world. This was a good call, as currently, Magna is one of the automotive giants when it comes to electrical components in vehicles, and various famous manufacturers tend to source these parts from the company. For example, mirror controls, seating electrics, and other electric peripherals for BMW are mostly done, but Magna. In addition to that, Ford and Volkswagen are both reliant on Magna when it comes to their EV components, and Mercedes EVs use entire powertrains developed by Magna. However, the biggest and most interesting part about Magna is the fact that Jaguar has put them fully in control over two of their vehicles, the F-Pace and the I-Pace. That's how incredibly big and important this seemingly unknown company is. However, one of their greatest achievements was their well-known powertrain, the Magna e-Drive. The Magna e-Drive, which was initially developed in the 2010s, has been a game-changer for the world of EVs. This completely new and radical powertrain promised a massive step forward in terms of potency, efficiency, and, above all else, ease of manufacturing. You see, one of the key reasons why companies like Stellantis, Tata, Mercedes, and many others are going to Magna to produce their EVs is the fact that the e-Drive is one of the easiest EV systems to install in a vehicle, be it an EV or a hybrid. For example, the Jaguar I-Pace that we've previously mentioned uses two complete e-Drive systems, as well as power electronics and integrated drive units, meaning that this entire platform is built from the ground up using only Magna's parts. This is also true for the new Fisker Ocean, which uses its powertrain and is also made by Magna entirely. Some vehicles, like the Volkswagen ID.4 vehicle, built from the ground up too. However, unlike the previous two, this one was developed by Volkswagen themselves, and they partially use the e-Drive system, showing how easily it can be integrated with vehicles that aren't designed for it specifically. The BMW iX3, on the other hand, uses the e-Drive system too, albeit the platform itself is developed, or shall we say, adapted from the regular X3, showing that the e-Drive is a powertrain that can be used without any restraints. Apart from this, Stellantis, Rivian, Hyundai, and various new manufacturers and startups tend to rely more or less on Magna and their e-Drive. However, that potency was brought to an even greater position earlier this year with the introduction of Magna's new electric motor. Magna's previous electric motor was regarded as one of the better ones on the market. With 400 volts, its remarkable 91% efficiency, a 2 kilowatt per kilo ratio, and a 16,000 RPM limit, the motor was solid, but ultimately unimpressive. It's for this reason that the I-Pace isn't regarded as either the best or the worst EV out there, just, well, in the middle. For example, it was outfitted with two e-Drive units, meaning two electromotors, which granted it a total of 400 horsepower. Not bad, however far from, say, a Tesla Model Y performance. Plus, it also had a relatively mediocre range of only 280-ish miles due to subpar battery management, which is something that Magna is generally known for. They are weaker in this regard than many of Magna's rivals. That's why Magna decided to completely throw it away and replace it with a new, more potent motor. You see, Magna has decided to virtually double down on the pre-existing motor and make it far more competitive than before. Starting with the RPM limit, the new motor has increased it to a whopping 20,000 RPM. This allows it to have a 3.3 kilowatt per kilogram ratio, making it almost 70% more potent than the previous generation. Because the motor weighs just 75 kilograms, This means that you'll have an output of almost 250 kilowatts, which translates to 335 horsepower. Oh, and have we mentioned the voltage of the new eDrive? Oh, there's no significant upgrade here. Only double the previous motor. That's right, 800 volts. This means that the charging speed will be practically twice as fast compared to the previous generation, as you can charge a vehicle using up to 350 kilowatts per hour. The reduced weight of the motor is a result of the change in voltage, not to mention that the motor will be more compact too. In addition to this, the new eDrive motor has an efficiency rating of 93%, which is astonishing, and is a big milestone towards the 100% efficiency that everybody is streaming towards. This means that only 7% of all electrical energy isn't being converted and is lost, which translates into a bit more power and a bit more range from a vehicle outfitted with a more efficient motor. Just so you have a better understanding of how important energy efficiency is, modern internal combustion engines have 3 times less efficiency on average. Oh, and let's also not forget that these motors will heat up much slower than a 400-volt motor, which means that they will be far more durable and have a higher projected lifespan. Now, this is all fine and dandy, however, one must ask, what are the real-life benefits of this? Let's be real here, nobody cares about power anymore. EVs are already as powerful as they are, and bringing more power into the equation means very little to us. However, the real benefit we'll see from the introduction of this motor is range. First of all, the increased efficiency of the motor will bring around 3 to 5% more range to the table, which isn't much, but it is a definitive improvement. In addition to this, because the motor is noticeably lighter, the vehicle will have to work a little bit less, and the power-to-weight ratio will increase marginally, which will, in turn, also marginally increase the range. Again, only a few percent. The fact that it'll heat up much less frequently also means that the cooling systems will work less, which once again extends the range a bit. Now, all of these things individually don't mean much, however, combined, you will get around 10% more miles on a full charge. And since we're talking just about a hypothetical motor change, and not the entire powertrain, this is a very good improvement. However, recharging the vehicle will also be a massive step forward, as it will now take practically half the time to recharge a vehicle with the same batteries as it used to. Also, something that many people forget to mention is the fact that the interior space, because of the noticeably more compact size, will also increase, and so will the cargo area. Are there any downsides to using this new eDrive system? Well, yes, there are. However, these issues won't be practical. Rather, they'll be far more, financially problematic, if you get what we mean. You see, 800-volt powertrains, similar to the new eDrive, have already been used by other manufacturers. Porsche has used it in the Taycan. GMC reserved it for the Hummer EV, and Tesla currently offers it only with the Cybertruck. So, essentially speaking, big 800V architectures tend to be far more expensive to make. This is because the electronics used, such as inverters, converters, and onboard chargers, need to handle considerably higher voltages, resulting in a far more expensive product. In addition to that, the battery packs are also more expensive, as they require adapting that allows more robust insulation, wiring, and various new safety measures that are required for noticeably higher voltages. In addition, albeit not mandatory, batteries oftentimes become even bigger than before to extend the range of these vehicles, which of course results in the price growing even higher. Now, this isn't a rule, however. Most manufacturers tend to do so nowadays. As a result of all this, an 800-volt eDrive will be noticeably more expensive than the 400-volt eDrive, which means that this will, most likely, be reserved for higher-end models. Now, this might seem like a bummer to you. However, this is a fairly common practice amongst EV makers. Furthermore, there is also the issue of recharging the vehicle. Sure, an 800-volt system can be recharged much faster, however, only if the charger allows it. And since 90% of EV models and an even greater percentage of EVs on the road in general utilize the 400-volt architecture, most chargers have been tailor-made for them. As a result, you'll hardly see the benefits most of the time, if ever. Oh, and there's also the issue of production. Sure, Magna is a big company, however, it will certainly have to convert some of their assemblies from the 400-volt eDrive to the 800-volt version, which will ultimately lower the profits somewhat, as the latter will be used on a somewhat smaller scale. However, all these issues are a regular occurrence for developing technologies. Heck, if you remember the early 2010s, you could barely charge your EV anywhere. and nowadays there's a charger at every corner. Not to mention that this isn't an all-new technology, unlike back then. It's just an evolution of an already existing technology. And building a new infrastructure from the ground up isn't necessary, but just modernizing it. In addition to that, albeit more complex to make at the moment, the complexity will lower as the scale of production increases and the use of materials such as silicon carbide and gallium nitride increases. Plus, with more and more vehicles using 800-volt systems, this technology will become more and more widespread and far more mass used than now. As a result of this, the price will keep dropping continuously, and this means that, soon enough, most EVs will come with such a powertrain as the e-drive, with 400 V1s being reserved for just the most affordable EVs.